we coalesced what understanding we have to date in 6 principles that we'll talk a lot more about this evening, but they are these 6, being problem-centered, problem and user-centered, paying attention to variation, understanding the system that gives rise to things, paying attention to measurement, having shared disciplined inquiry, and organizing collectively in networks. A little bit about some of our work, moving the needle on developmental math in community colleges. When I say developmental math in community colleges, how many people here know what I'm talking about? So, one way to think about developmental math, it's that math, I probably have some of that here at the University of Wisconsin as well, is that math you take when you leave high school often, believing that you passed mathematics in high school, and you show up and you take an exam, and the institution you want to go to says, no, you need to take more math in order to be ready to be prepared to take college level mathematics. And this is important because taking college level mathematics is the gateway to many careers that people want to join. So 60 to 70% of community college students wind up being placed there. 80% of those students never get out with a college, ready to take, prepared with a college credit in mathematics. So that's a whole lot of people who then effectively have opportunities shut down for them. The typical course of study is you have to have elementary algebra, intermediate algebra, and then you get to take college math. You get a college math credit. The work of colleagues at the foundation, we created 2 new ways to and through developmental mathematics. One based on quantitative reasoning, the other based on statistics. So the spine of teaching developmental mathematics was wrapped around these 2 approaches. And we made it possible to not get lost in the switches, in the cracks. Sort of 1 year-long course. So if you're in for a penny, you're in for a pound. In addition to doing that, our colleagues at the foundation, from looking at the problem, we attempted to come up with a practical theory that would guide our work in trying to address this developmental mathematics problem. So the goal was to change developmental mathematics as a gatekeeper. And we felt like it had, our analysis of the system helped us understand there are a bunch of parts in making that happen. Well, there's institutional structures, there's leadership attention, there's the instructional system, which we paid a lot of attention to that, sort of building new curricula, paying attention to the collaborative context of work among faculty, and to present ambitious learning goals to students. Students need to know how to work hard and how to persist. So a big part of this work was helping students develop a mindset that would get them through developmental mathematics. Developmental mathematics, most instruction today places huge language and literacy demands on learners that many learners aren't prepared to take up. So a strand of the work was trying to understand, to help students read more effectively and to help the language inside materials not to be such a barrier. And we worked on comprehensive programs of professional development to help faculty understand the underpinnings of teaching better and to help faculty leaders to become collaborators with us in improving curriculum. What did we see? So here you see a comparison of 1 year in Statway by comparison to 2 years in the standard sequence and the success rate. As you can see, that success rate, the 2-year success rate hovers around 14% for the standard way through, and students taking Statway were up around 50% success. So so you're getting far more success in less than half the time. And this happens when we have, as the number of students who are part of the program goes up. So we are able to maintain these results as scale increases. Further, when we look at some communities that have been challenged by courses like these, the results seem to maintain. So we are now serving more than 50 institutions, and the work has touched more than 20,000 students. And to be clear, this comes from paying attention to the details of practice, paying attention to the work that people do, and also trying to organize the work so people can work more effectively together.